In addition to being really valuable, gold has some amazing properties. For one, it's the most malleable of all the metals, meaning it can be beaten into very, very thin sheets, 1,000 times thinner than a sheet of paper. Maybe gold was the inspiration for Democritus, the Greek philosopher who began the search for a description of matter more than 2,400 years ago. He asked, could matter be divided into smaller and smaller pieces forever, or was there a limit? He proposed that eventually the smallest possible piece would be obtained. This piece would be indivisible. He named the smallest piece of matter atomus, meaning not to be cut. About 2,000 years later, John Dalton, an English chemist, expanded on Democritus's idea. Dalton, who did many experiments with states of matter and heat, came to the conclusion that all bodies of sensible magnitude, whether liquid or solid, are constituted of a vast number of extremely small particles or atoms of matter. Since then, atoms are considered to be the basic building blocks of all matter. But even the building blocks have parts. The atom is made up of three types of particles: protons, neutrons, and electrons. These particles are always the same no matter what the atom. What varies is the number of each particle in the atom. For example, the simplest atom is hydrogen. It contains just one proton and one electron. Adding another proton, two neutrons, and another electron makes helium. The neutrons and protons combine together in the center. This is the nucleus of the atom. The electrons orbit around the nucleus, although in reality the orbit is much bigger than indicated here. Protons carry a positive charge, and electrons carry a negative charge, and neutrons carry no charge. This helium atom has two negative charges and two positive charges, so the overall charge is neutral. Atoms are normally neutral because they have the same number of protons and electrons, but as we'll see later, atoms can carry a positive or negative charge. The symbol for hydrogen is H, and it contains one proton. Helium has two protons. Lithium has three protons, and so on. By arranging atoms by their number of protons, scientists have created the periodic table, which is a way of organizing all the known elements. Let's find gold on the periodic table. The symbol for gold is Au, which is derived from the Latin word aurum, for shining. Alright, there it is. Let's look more closely at what's in the box. The 79 in the corner is the atomic number, and represents the number of protons in the gold atom. Gold has 79 protons. Underneath the symbol we have the atomic mass. This is the actual mass of the entire atom. Yes, atoms can actually be weighed. Protons and neutrons are considered to have a mass of 1 unit each, or 1 AMU. Electrons are much lighter, about 1/2000th of the mass of a proton, so their effect on the mass is negligible. A gold atom has a mass of 197 atomic units. Since there are 79 protons each with a mass of 1 unit, we can calculate that there are 197 minus 79 equals 118 neutrons. The periodic table contains all of this plus several other layers of information that make it a very useful tool in chemistry. The periodic table contains all the known elements, but what about some common substances like water? They are not elements. Why? Well, an element is a substance made from a single type of atom. In gold, all the atoms are identical. Water is made up of two types of atoms, hydrogen and oxygen. Actually, there are two hydrogen atoms and one oxygen, giving us H2O. When two or more atoms form a compound, it's called a molecule. Atoms with the same number of protons and electrons are neutral in charge, but electrons can be lost, leaving the atom with a positive charge. A positively charged atom is known as a cation. Atoms can also gain electrons, creating an anion. Atoms in a charged state, whether negative or positive, are called ions. Let's look at a common example of a compound made from ions. This compound involves the metal sodium and the gas chlorine. When sodium loses an electron, it becomes a positively charged sodium ion. When chlorine gains an electron, it becomes a negatively charged ion or anion. In a process called ionic bonding, the opposite charge of these atoms attracts them together, forming sodium chloride, or better known as table salt. Understanding the way electrons are shared is an essential part of chemistry.